Ping is working, and trace route 20.1.1.1 source 30.1.1.1 numeric. See, traffic is going directly, right? But guys, if I don't have circuit here, then you have to configure a static neighborship, right? Like on hub router, you will run this command, router EAGRPS number 10 and define neighbor. Who is the neighbor? IP address of neighbor 192.168.10.2 and then AS number of neighbor. First on the interface, so fast Ethernet 0/0. On fast Ethernet 0/0, I have defined one neighbor. Do so IP EAGRP neighbor. Now neighborship is done. On the fast Ethernet 0/0, I have configured a static neighborship. So make sure on other end also you have configured a static neighborship. So on router number 2, I'm going to say router EAGRPS number 10 and neighbor 192.168.10.1 on which interface? On fast Ethernet 0/0. Now so IP EAGRP neighbor. Now these routers are going to exchange hello message on unicast IP address. And now you can see we don't have neighborship between router 2 and router 3. Now on router number 3, I am going to say router EIGRP S number 10 and who is neighbor 192.168.10.1 F0/0. So IP EIGRP neighbor. What depends? So IP EIGRP interface. So EIGRP is enabled on both interface. Debug IP EIGRP, debug EIGRP packet hello, debug EIGRP packet hello. So this router is sending hello message from the loopback interface. It should not send hello message from the loopback interface. What solution I have? It is sending from both interface, from 0/0 also, from loopback also. But I don't want that this router should send hello message or any message of EIGRP from the LAN interface. So what option I have, guys? Router EIGRPS number 10, passive interface, right? Passive interface, loopback 1. Now it will not send hello message from loopback interface, and this command should be enabled on all interfaces, means on all the routers. Like here also say passive interface loopback 1, and on router 2 also router EIGRPS number 10 and passive interface loopback 1. So interviewer can ask you this question also, how to stop EIGRP messages on LAN interface. So always keep in mind the feature which we are using is passive interface, right? Not only in EIGRP, in RIP also, in OSPF also. To stop routing protocol messages on the LAN interface, we are configuring that interface as passive interface. Clear? Now why we don't have neighborship between router 1 and router 3? So IP EIGRP neighbor. Router 2 is the neighbor. Because guys, so run section router EIGRP. See, I have not defined neighbor 192.168.10.3, right? So actually I need to add one more command here, router EIGRPS number 10 and say neighbor 192.168.10.3 on which interface? On F0/0. Now you can see there are two neighbor command on 0/0, and that's why now we have neighborship. So IP route EIGRP. This router is learning 20 network and 30 network with help of EIGRP, correct? Now what is the issue here? So IP route EIGRP. See guys, router 2 is learning 20 network. No. Router 2 is not learning 20 network. See, for this network, exit interface is null 0. Whenever router will find exit interface null 0, router will drop the traffic. So why, tell me the reason guys, why router 2 is not learning 20 network here? And on router number 3, so IP dot EAGRP 30 network. Now remember, recall all features of EAGRP and let me know. On all, I have disabled the debugging. So IP route EAGRP. Router 1 have route, means router 1 can ping LAN user from the hub. Router can ping to remote users like 20.1.1.1 source 10.1.1.1. See, ping is working. I can ping 30 also. 30 also, right? On router number 2, so IP route EAGRP. For 20 network, exit interface is null 0 20. So IP interface brief exclude and assign. Now R2 don't have route for 30 network and R3 don't have route for 20 network. So IP route EAGRP don't have route for 20 network. Why? Okay, let me ask you another question. See, on router number 2, so IP EAGRP interface. EAGRP is enabled on F0/0 as well as on loopback 1. Router EAGRP is number 10 and network 20.1.1.0 255.255.255 dot. Loopback interface is up. So run section EAGRP. Let me do one thing. Let me disable automatic summarization as well. Router EAGRP. See, by default, automatic sum on some devices by default automatic summarization is disabled, right? But on the previous iOS version, guys, by default automatic summarization is enabled. So simply I can say no auto summary. So IP EAGRP interface. So IP EAGRP interface. So IP EAGRP interface. Because I have configured loopback interface as passive interface, right? So it will not show you that interface in EAGRP now. So IP route EAGRP, but on so IP route EAGRP. Here why I don't have 30 network and how to fix it? How to fix is, let's suppose interviewer is asking you this question that they can draw this diagram on the paper. They can ask you router 2 is not learning this network and router 3 is not learning 20 network and router 2 is not learning 30 network. We have EAGRP neighborship between hub and spoke. Like this you can have multiple spoke, right, at different location. Which type of topology it is? A star topology, right? What is the issue? Hey guys, what happened? Yeah, very good. A split horizon. What is happening? Router 2 is going to share their network information to their neighbor. So IP EAGRP neighbor. Who is the neighbor? Router 2. So IP EAGRP neighbor. Who is neighbor? 192.168.10.1. So router 1 will share this network to 10.1, means to router number 1. Router 1 will receive it on this interface. Can router 1 will forward same network information from this interface? No, because of split horizon. So sometime you need to disable split horizon as well, right? Sometime you need to disable split horizon, like in this scenario, guys. In the hub and spoke topology, you have to disable split horizon. So on router number 1, I'm going to disable split horizon. Interface F0/0 say no IP split horizon for EIGRP number 10, right? After disabling EIG split horizon on this interface C, router 2, so IP dot EIGRP. Still we don't have route. What happened? Now why I don't have route here? So IP dot EIGRP. Why I don't have 30 network? On router number 3 I have 10 as well as 30, but I don't have 20, and on router number 2 I have only 10. But for 30 here you can see exit interface is null 0. This is because of automatic summarization. Router EIGRP 10 and say no auto summary. On router number 1 also I am going to disable automatic summarization. Router EIGRPS number 10 say no auto summary. So IP route EIGRP and so IP route EIGRP. What is the issue now? I have disabled split horizon, but still branch offices router don't have route. Okay. When, tell me one thing, when router 2 will advertise this network to router number 1, what will be next hop IP address, guys, on router 1 for this network, for 20 network? Next hop IP will be the IP address of exit interface, IP address of this interface, correct? IP address of exit interface. On router number 1 you can verify it. For 20 network you can see next hop is 10.2, right? For 30 network next hop is 10.3. Right? So router 2 is advertising this network 21.0.0.0/24 and source IP address 192.168.10.2. Destination IP multicast address 224.0.0.10. It will forward to router number 1. You have disabled the split horizon, so router 1 is going to forward it to router number 3. But from router number 3 is next hop reachable? From router number 3, ping 192.168.10.3. Yes. Sorry, 10.2. Yes. So IP route EIGRP. Interface F0/0 no IP, just wait, next hop self. I think this is the command for EIGRP 100. Why branch offices are not learning the network information, guys? Hub means a spoke network information. What is the issue? So IP EIGRP topology. Sorry, not on router number 1, on router number 2. So IP EIGRP topology. Is remote network available in topology table? 30 network. No, not available. That means router 2 is not learning, means not receiving 30 network from router number 1. But on router number 1 I have disabled the speed horizon as well. So this was the concept in this topology, like you need to disable, you need to enable, sorry, you need to disable speed horizon over here. No IP split horizon for EIGRPS number 10. Now router 1 should advertise remote network information. Now do one thing, let me do one thing. On router number 2 I am going to add one more loopback, interface loopback 1, and IP address over here is, let's say, 20.1.2.1.255.255.255.0, and let me advertise it in EIGRP, router EIGRP S number 10. And before that, let me capture this link also. Done. Now network 20.1.2.0 255.255.255.0. Done. Router 2 will generate update message. Here is the update message, and in the update message it is sharing both network. So see, this is actually partial update. Router is sharing only changed information, guys, right? Router is sending only changed information. And on router number 3, so IP EIGRP topology, or so IP route EIGRP. (20.1.2.0). Now router 1 don't have 20.1.1.0 network in their topology table. Oh, I have key. Sorry. Interface loopback 2 and IP address 10.1.20.1.1.0. Yes. Right. And network is already running, so IP EIGRP topology. Yeah. So in the next update message, set I did some mistake, right? So IP interface brief, I think I have created loopback on router number 1. Yes, this one. Let me say no interface loopback 2. Extremely sorry. On router number 2, interface loopback 2 and IP address 20.1.1 255.255.255.0. Now here is the update message, and this time router is sending which network information? 20.1.1.0. But here I am not able to see any update message of router 1. That router 1 is sending to other router means router number 3, right? Or what other option you have, you can do one thing on router number 1, you can enable debugging, debug EIGRP packet update interface loopback 3 IP address 20.1.3.1 exit router EIGRP as number 10 and network 20.1.3.0 receive update message on fast ethernet 0/0 from this neighbor. It will add that in their topology table. After that, router 1 should generate one update message for the another neighbor, right, for spoke 2, but it is not generating. So run section EIGRP. No IPSP reason, that is fine, everything is correct here. So IP EIGRP neighbor. So this can be, I think, issue of simulation software then, but in simulation also it was working, I remember. So IP EIGRP topology. No, तो passive interface तो उस पे configure है LAN interface पे, that is not the concern. But I have created 2 new loopback on router number 2 and passive interface is not enabled here. And passive interface is, you know, the concept of passive interface means do not send message from the passive interface, that's it. It will include that network in EIGRP topology table. So you can see in the 20.1.1.0 is still there. 2.0, but why router 1 is not forwarding traffic to their other neighbor, update message to other neighbor? This is the issue here only. IP split horizon for EIGRP is number 10. So IP EIGRP topology, still router 2 is not receiving 30 network. Interface F0/0, no IP split horizon for EIGRP is number 10. Sending update from fast ethernet 0/0, no. Router 3, so IP EIGRP topology, no. Here I have to turn off this device, these devices, and then again I have to turn it on. Means I have to reload the device to check why it's not working. And guys, what you can do, you can configure same thing on other series router in GNS3, right? It will work. So here in this topology, actually you need to perform lab of 2 things. One, split horizon, you need to disable split horizon, and you need to change next hop IP address. You need to run command no IP next hop self. Why no IP next hop self? Because when router 2 will advertise this network to router number 1, router 1 will install it with what next hop? With the IP address of this interface. When router 1 will advertise same network to router number 3, it will update next hop IP address, correct? It will set there on next hop IP address. So router 3 will learn this network 20 network via router number 1. Now guys, whenever LAN user from this network will communicate with this LAN user, right, these users will communicate via hub router, via router number 1. But your scenario can be, and most of the time what we want, that EIGRP route should be extended via hub router, but remote branches should be communicate directly. Should communicate directly. So you have to tell to router number 1, brother, please don't update next hop IP address whenever you are advertising a network to another remote branch router. Got it? Which series router it is? 373725. Maybe on this series router it's not working fine. And one more thing on router number 1, router stub. I have configured this router as stub router, correct? Router EIGRP10, no EIGRP stub. This was the issue. Now it is sending update message. Now go to router number 2, so IP EIGRP topology. Now it is learning 30 network, correct? Now router 2 is learning 30 network, and what is the next hop IP, guys? IP address of hub router. Means these two branch offices will communicate via hub router. Ping 30.1.1.1, source 20.1.1.1. Ping is working, and trace route 30.1.1.1 and source 20.1.1.1 numeric. Traffic is going via 10.1, means hub router. Reason, so IP route EIGRP. See the next hop IP address for this network, 10.1. And always keep in mind, a stub router should be your edge router, right? Like here, router 2 and router 3. These are edge router, correct? So these routers should be configured as stub router. Right? And guys, in last class we had discussed one scenario like this. R1 is connected with two different router, then there is again two different neighbor like this. So in this scenario, these routers are edge router, correct? So whenever router 1 will generate query message, this edge router will generate reply. Am I right? This edge router will generate reply message. So, and this edge router you will configure stub. These routers should be stub router. Now, if you want that two branch offices should communicate directly, what you can do? On router number 1, simply you can disable next hop self. By default, next hop self command is enabled. That's why router 1 is updating next hop every time. Here I can say no IP next hop self for EIGRPS number 10. And now on router number 2, I am going to clear IP route star and see show IP route EIGRP now. Now 3430 network next hop is router 3, correct? So now if I will trace route 30.1. Trace route 30.1.1.1 and source 20.1.1.1 numeric. Now you can see traffic is going directly, correct? Got it? Now we have variance. So let me do one thing. In this type of topology, hope you can configure these two features and you can explain these two features in interview like speech horizon and next hop self. In this type of scenario, only required in these two types of scenario, not everywhere. Now guys, let me discuss variance. For that I am going to close this topology and let me open the another topology, this one, EIGRP routing, this one, where we have multiple paths between source and destination. this one. Between source and destination, now I have how many path? 2 path. And guys, by default router 1 and router 2 is going to perform what? Load balancing, because see, everywhere I'm using same link, fast Ethernet link, so metric will be same from the both path. But what I will do, I will change some metric or bandwidth or delay. I will change metric or delay. So let me check EIGRP is running here. So IP protocol, no. So IP interface brief, done. Router EIGRP number 10, say no auto summary, and network 0.0.0, do show history. Let me copy the command and I'm going to paste this command on all routers. On router number 3, on router number 2 also, and on router number 4 also. Done. Now let me take you to R1 and see, we have two neighbors. So IP EIGRP neighbor, both are neighbor. 14.4 is router 4 and 13.3 is router 3. Now guys, so IP EIGRP topology table. So IP EIGRP topology, how many paths are available for destination network? For 20.1.1.0, 20.1.2.0, 20.1.3.0. For all network, 2 paths are available. And see, the metric is same or different? Metric is same or different? Same. So router is going to perform, R1 is going to perform load balancing. So IP route EIGRP, you can see it is not performing load balancing. Why? So IP EIGRP topology, metric is same or different? Different. Metric is not same. FD. FD means total distance from source to destination is different. Best is, lower is via which router? Lower is via router number 4. So that's why it have installed best path via router number 4. Why metric is different? Maybe you have changed the bandwidth or delay. So run interface F0/0, F1/0. Here I have not configured any bandwidth and delay. On router number 3, so run interface F0/0 and F1/0. Nope. So run interface F0/0 and so run F1/0. No. So run interface F0/0. (0/1). No, then why metric is different? Metric should be same. So IP EIGRP topology, router 1 should perform load balancing. Let me check on router number 2. So IP EIGRP topology. For 10 network, here metric is same or different? Different. But guys, RD is, this is CFD. First value is FD, second value is RD. RD is same from both neighbor, but FD is different, right? That means their receiving interface bandwidth and delay is different. So IP interface, not IP, so interface F0/0 include bandwidth of this interface is, and bandwidth of F1/0 different or same? Different, right? So run interface F0/0. See, here I am not able to see any bandwidth command on F1/0. No, think it will not. Running configuration of this interface, here it should. So run. So run interface F0/0 include bandwidth. On this interface, I am going to set default bandwidth. Interface F0/0, no bandwidth 1, this value. By the way, it should, when you will run command so run interface F0/0, it will show you all enabled command on that interface. But here it's not showing. Now, if I will check the bandwidth, this interface and F1/0. So on interface F1/0 also I am going to set same bandwidth. How many 0? 50, right? Now so IP route EIGRP. So interface F0/0 include bandwidth. Delay is 1000 here, and on F1/0 what is the delay? 100. Oh, delay is different. On F1/0/0 interface F0/0 delay done. Now so IP route EIGRP. So IP EIGRP topology. Two path, and this time see metric is same. So IP route EIGRP. Now router is performing what? Load balancing. So this time guys, router is performing load balancing because cost is equal, because metric is equal from both sides. So this type of load balancing is called what? equal cost load balancing. This type of load balancing is equal cost load balancing. In the same way on router number 1 also, so run interface F0/0 and on F1/0, not showing any command, right? So interface F0/0 include bandwidth. So delay over here is 1000. Let me set delay 100. Interface F0/0, say delay 10. Now show IP EIGRP topology. Now for 20 network, here also metric will become same. Wait for next update message. Now you can see metric is same, and router 1 will also start performing load balancing because cost is equal from both sides, right? So guys, both router 1 and router 2, both routers are performing equal cost load balancing. Now question is how we can achieve unequal cost load balancing. So first thing to achieve unequal cost load balancing is alternate path or backup path should be available in topology table. Alternate path should be available in topology table. So see here again I am going to change delay on F1/0. Let me set delay 100. So IP route EIGRP. Now soon it will install one path, best path in their routing table. Wait for next update message. So IP EIGRP topology. Now see metric is different, right? So it will install only one path. So IP route EIGRP in their topology table, in their routing table, correct? But this time I want to achieve load balancing here on router number 1. So guys, to achieve unequal cost load balancing, this time if router will perform load balancing, then that load balancing will be unequal cost load balancing because cost of both paths is unequal. Am I right? So to perform unequal cost load balancing, the first feature which we have is variance. Variance. Now question is, what is variance? So variance is, it is used to perform unequal cost load balancing. It is used to perform unequal cost load balancing and it is 7 bits value. So what can be the range of variance guys, and represented in decimal? It is 7 bits value represented in decimal. Then range will be 1 to 127, sorry 128, and variance is applicable only on feasible successor. So right now to perform unequal cost load balancing on router number 1, you have to check topology table that in the topology table feasible successor is available or not. So IP EIGRP topology. So see, feasible successor is available for 20 network. Yes, feasible successor is available. This is feasible successor via router number 4. Via router number 3 successor. To open it in detail, what we can say is, so IP EIGRP topology 20.1.1.0 like this. See the detailed information of this network. Like a state of this network is passive, and a state should be passive. If a state is active, that means EIGRP is not stable. Correct guys? How many successor is available for this network? One successor. And what is the FD? Means total distance between source and destination. 41210 for the successor, right? For the successor means from the best path, this is the FD. And this network best path is reachable via 13.1.1.3 means router number 3 on fast Ethernet 0/0. There are two types of route in EIGRP, internal and external. We will discuss about it later, don't worry. Minimum bandwidth, total delay which router 1 is receiving from their neighbor from 13.1.1.3. Reliability, load, MTU, you can see these all things. Hop count, how many hop this network is away, 2 hop away. See, destination network 20 network is 2 hop away from router number 1, correct? And then feasible successor path via 14.1.1.3. this is what feasible successor. So if feasible successor is available, then you can perform load balancing. Now what variance says? So variance is nothing but a multiplier of FD, multiplier of FD. By default variance value on the router is 1. And see guys, what is the concept of variance here? Router is actually calculating multiplying variance value with FD of feasible successor, FD of feasible successor, and by default variance is 1. So 1 multiply by FD of feasible successor, this path, right? Let's say X. It will get same value. But if you will change the variance value to 2, then value will be what? 2x. After that, router is going to check their topology table. Is there any path available whose FD is lower than 2x? If yes, then it will install that path in their routing table. If yes, then it will install that path in their routing table. By default variance value is 1, so it is getting same value. So see, if I will set variance value 2, then will router 1 perform load balancing? How to verify it? What should be the variance value to achieve unequal cost load balancing? For that, what you need to do guys, you need to find what FD value of successor and feasible successor. So FD value of successor, FD of successor is this one, correct? Let me paste here. And FD of feasible successor is this one. So concept in EIGRP is EIGRP protocol always check their topology table. Always check their topology table to find best path. And EIGRP multiply feasible FD of feasible successor with variance value. Variance value with FD of feasible successor. So by default variance value is 1. It will multiply that value by 1. What value it will get? Same value. Now it will compare, is there any path available with metric lower than this multiplied value? If yes, then it will install it in the routing table. So guys, if I will set variance value 2, then what will happen? It will multiply FD by 2. FD means successor. 2. It will get one new value, and then it will compare their topology table. Is there any path available with lower metric, with lower FD value? If yes, then install it in their routing table. This is concept of variance. So what is variance? Variance is just a multiplier represented in decimal. It is 7 bits value. Range is 1 to 128, and it is applicable only on feasible successor. If feasible successor is not available in the topology, then you cannot perform unequal cost load balancing by using variance. And before talking about the unequal cost load balancing, one most important thing, which path will become feasible successor? Which path will become feasible successor? So guys, there is one feasibility condition, and that feasibility condition is FD of successor must be greater than and equal to RD of feasible successor. So if this feasibility condition will match, then only router is going to install backup path in their topology table. And if backup path is available in the topology table, then only we can achieve unequal cost load balancing. FD of successor must be greater than or equal to RD of feasible successor. So see here, this rule is matching. That's why router 1 have installed both path in their topology table. RD of feasible successor is this one, and FD of successor is this one, correct? So guys, FD of feasible successor is greater than RD of, sorry, FD of successor is greater than RD of feasible successor. That's why this path is feasible successor. This path is backup path, right? And to verify the variance value, you can run command show IP protocol. So what is the variance value by default? 1. What will happen if I will set variance to router EAGRP as number 10 and say variance 2? So IP EAGRP topology. In the topology table, two paths are available, and so IP protocol. Now variance value is 2. So it will multiply FT by 2, and it is going to check is there any path available with lower metric than multiplied value. If yes, then install it in the routing table. So IP.EAGRP, and now you can see it have installed both path. Is metric same? No, metric is different. FD is same or different, guys? Different. Then also router 1 is performing what? Load balancing. So this type of load balancing is called unequal cost load balancing. Unequal cost load balancing. Okay. So to find the variance value, how to find variance value? You can divide FD of successor by FD of feasible successor. You can divide FD of successor by FD of feasible successor to get variance value. Like what should be the variance value? Done. So this is first one type of unequal cost load balancing. Now the second type of unequal cost load balancing is offset list. Is variance clear? See, by default, so IP protocol, by default it can perform load balancing for up to 4 paths. It can install 4 paths in their routing table, up to 4 paths. Router EAGRP is number 10 and maximum path. And how many paths you can configure? Up to 16 paths. Done. Any other question in variance? In the same way, on router number 2, also, if you want to achieve load balancing, you can configure variance. Right now router 2 is not performing load balancing, I think. So IP.EAGRP, okay, it is performing equal cost load balancing. So let me do one thing, let me change bandwidth or delay. F0/0, say bandwidth Wait for some time. Done. Now router 2 is not performing load balancing. But if you want to perform load balancing, check topology table. Is backup path available in the topology table? So IPAGRP topology. Yes, backup path is available in the topology table. That means feasibility condition is matching. And if alternate path, backup path is available in the topology table, then we can perform unequal cost load balancing with the help of variance. Here again, we need to increase the variance value. And the second method is offset list. Offset list. Now guys, again on router number 1, I am going to set variance value 1. Router EAGRP S number 10 and variance 1. And so IP route EAGRP. Sorry, on not on router number 2, yeah, on router number 1. Router EAGRP S number 10 and say variance is 1. So IP route EAGRP. Now router 1 is not performing load balancing. Now I am going to perform unequal cost load balancing with the help of offset list. First of all, again, what is offset list? So offset list is also used to perform unequal cost load balancing like variance. It is used to perform path manipulation also. Like here, what I want, see by default which path is the best path? Via router number 3. Via router number 3. But if you want to install lower path as the best path, you can with the help of offset list. So this is what path manipulation. What I can do, I can increase the bandwidth on the upper path. I can add some bandwidth on, add some metric on 0/0 FT value. So this time, so IP-EAGRP topology, see for 20.1.1.0 network, there are two paths. FD from the upper path is this one guys, and FD from the lower path is 435200. Correct? With the help of offset list, we can add metric. We can add extra metric with existing metric. So what is the difference in metric? Calculator. 435200 minus 41260. The difference is this one, right? The difference is this one. So guys, if I will add this metric in the lower path or in the upper path, if I will add this metric here, then what will happen? Metric will become same. Then metric will become same both side, correct? Yes or no? And same thing we are doing with the help of offset list. With the help of offset list, what we can do, we can add some metric. If I will add one more here, one more metric, then what will happen? Lower path will become best path, right? If I will add 41 here, then lower path will become what? Best path. So to perform unequal cost load balancing or to perform path manipulation, we can use offset list. We can include metric with existing metric by offset list. or you can see we can add metric. To configure it, first of all you have to define interesting traffic. Like guys, first you have to define the traffic, for which traffic you are going to add metric, for which traffic you are going to add metric. And guys, to identify the traffic on router, we have again multiple features. First feature is access list. Access list, we will talk about access list. There are multiple use of access control list on router. Right now I am going to use access list to define the traffic. Like I want to tell to router number 1, bro, I'm talking about this network 10.20.1.1.0/24. So I can use ACL. By default, if I'm saying please add metric 5, how router will came to know for which network I need to add metric 5, right? So see what I can do. On router number 1 I can create one access list, and we will discuss access list soon guys. Maybe after this class tomorrow or after tomorrow we will start access control list, right? For now here I am going to create access list number 10, then say permit, and network 20.1.1.0 subnet mask 255.255.255.0. Here I will use wildcard mask. So we will discuss wildcard mask as well. Wildcard mask is nothing but opposite of subnet mask. So subnet mask for this network is 255.255.255.0. So wildcard mask will be 0.0.0.255, right? Don't worry, we will talk about wildcard mask as well soon. Now guys, I'm going to use offset list. So say offset router EIGRP S number 10 offset list, and then I'm going to call access control list. See, in the access control list 10 I have defined this network, right? So why I have created ACL number 10? Just to define this network, just to make this network as interesting network on router, right? So let me call to ACL, which is 10, right? Then guys, in which direction you want to add metric? Let's suppose I want to add in direction, right? Means whenever router will receive the network, which network? Which is defined in access list 10. Which network is defined in access list 10? 20.1.1.0/24. So whenever router is going to receive this network, it will add metric. If I am saying auth, so whenever router will advertise this network, it will add metric. So for now, let me say in direction, and after that guys, what metric you want to add. What metric you want to add, see the range of metric. So difference is this one 23040. If I will add this metric, then FD will become same on both path. But if I want to manipulate the path, I will increase the band metric here. I have add 23401, right? Now see, do so IP protocol. Variance value is still 1. Is there any command redistributing AGRPS number 10? Incoming route will have 23041 added to metric if on list is 10, right? And list 10 is your access control list. Do so access list. In access list 10 you can see the subnet is 20.1.1.0. And one more thing here I can define, like interface. On a particular interface if you want to add, so say interface F0/0. Interface F0/0, not here, offset list. Where is the offset list command? Here. On which interface? On interface F0/0. Okay, fast Ethernet 0/0, like this. Now do so protocol. So now you can see we are adding metric on fast Ethernet 0/0, right, in indirection. And now if you will check topology table, so IP EIGRP topology. So IP EIGRP topology. So see guys, for 20.1.1.0/24, it has added metric on both path. It has added metric on both paths because earlier I didn't define the interface. So I am going to remove this command, this command, and now say offset list on fast Ethernet 0/0 only. Now do so IP EIGRP topology table for 20.1.1.0. For 20.1.1.0, see now metric is same or different? Where is the lower metric guys? On the lower path, right? So it is going to install which path in the routing table? Do so IP route EIGRP lower path. These all REST networks are still reachable via upper path. Best path is upper path, but this 20.1.1.0 is best via lower path because of offset list, right? This is what path manipulation. But if I want to achieve load balancing, I will remove this command, say no, and then say offset list, and let me add this metric 23040, right? And now do so IP EIGRP topology or route. Okay, route. EIGRP topology. Now you can see for 20.1.1.0 metric is same. So check the routing table. So IP route EIGRP. Now router 1 is performing load balancing for this network 20.1.1.0/24, right? If I want to perform load balancing, unequal cost load balancing for these three network, for all network, what I need to do? I need to edit access control list. So say no access list number 10, and I am going to create access list number 10 permit, and this time I am saying 20.1.0.0 wildcard mask 0.0.255.255, right? All network will match here, right? This time it will match only 16 bits. So now see, do so IP route EIGRP, just wait, do clear IP route star. Do so access list. This is my access control list. Do so IP EIGRP topology. For this network, still metric is different. Clear IP EIGRP neighbor, and so IP route EIGRP. Now you can see, correct? It is performing load balancing, right guys? For all network. So this time see cost is metric is equal from both sides. But this is not by default metric, right? We have configured offset list to make metric equal. So that's why we are saying this is also unequal cost load balancing. Now the third concept in EIGRP is summarization. Guys, see, router 2, if any network will goes down, debug EIGRP packets query. If any loopback interface will goes down, interface loopback 1 says shut down. Router 2 will generate what query message? See, it is generating query message, right? But I want to reduce this query message. What I can do, I can perform summarization here. I can perform summarization, and summarization is useful for path manipulation as well. Like this time router 2 is advertising these all network from two side to router number 1, right? Router 1 is learning from two side. But if I will summarize this network from here, what will be the summary address? 20.1.0.0/21, I think, right? 21. So now guys, router 1 is learning here 20.1.0.0/21 network, and here it is learning all individual prefixes, right? So router will install both path in their routing table, but while forwarding traffic, router will use lower path, because from the lower path still it is receiving all individual prefixes, means prefix length is going to be 24 from the lower path. Right. Second use, to reduce the routing table. Right now you can see router 1 have 3 paths in the routing table. So it is not necessary that you should perform summarization on router number 2. You can even perform summarization on router number 3, router number 4, or router number 1. That is what manual summarization. So what I can do here, I can simply say interface f0/0 IP summary address, then network. What will be summary address? Summary address of these three network. Convert the value in binary where value is changing. So value is changing in third octet, right? Binary of 1 is, right? Binary of 2 is, binary of 3 is. How many bits are common, guys, in third octet? 6. 6 bits are common. So 8 plus 8 plus 6. What will be CIDR value after summarization? Correct, 22. So what I can do, I can say 120.1.0.0, and what will be subnet mask for /22? Subnet mask for /22. 252.0, right? Now you can see on router number 1, clear IP route star and show IP route EIGRP. This is the summary network information. I should run this command on router number 2. So IP route EIGRP. See the path manipulation. From the upper path it is learning only summary network, and from the lower path it is learning all individual prefixes, right? So guys, if router will receive a packet where destination is, let's say, 20.1.1.1, router 1 will forward to which router? To router 2 or router 4? To router 4, right? Because here see, destination is matching in this entry also and in this entry also, but here prefix length is 24, right? So it will prefer this network, this route. It will prefer this route. So earlier router was performing load balancing, this time router 1 is forwarding traffic from lower path. This is what one kind of path manipulation. This is what? Path manipulation. And you have performed the summarization. Now see one more thing here. Debugging is enabled, say no shut. And what will happen if any network will goes down? Interface, loop back, let's say 2, say shut down. Will router 2 generate query message? Yes. It is generating query message, correct? But guys, router, other routers means router 2, except router 2, router 1, router 3 and router 4, these routers are not going to generate query message for summary network. Like see on router number 1, on router number 1 show IP route. If this network will goes down 20.1.1.0, router 1 will not generate query message. Reason, summary route is available, right? So here we can enable debugging EAGRP packet query, and here say no shut, and then interface loopback 1 say shut down. Receive query message, right? But router 1 is not generating any query message. It have received query message from both neighbor, but router 1 have, it will send query message from the one path where it is receiving individual prefix. So IP route EIGRP. From one path it is still receiving individual prefixes now from the lower path. And for the summarization, it will be very good if you will design topology like this: R1, R2, R3 and R4. Then on any router you can create some loopback. Let's say on router number 1, 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24. After that, advertise summary route from router number 1 and then check router 1 is generating query message or not. So other routers like router 2. Router 2 will learn these all network information via router number 1. So if any network will goes down, then router will generate query, router 2 will generate query message. But if router 2 have summary route, and then guys, if one individual network will goes down, then router will not generate query. So summarization is useful to reduce query message as well. If here I have router 1, 2, 3, connected like this. On router number 1 I have some network. Router 1 will advertise this network information to their neighbor, to router number 2 as well as to router number 3. Right? Router 2 will advertise it with their neighbor to router number 4, and router 3 will also advertise it to router number 4. And after that all router will have network information. But suppose from this side, from upper path on router number 4, means via this path I am advertising summary network 10.0.0.0/8, and router 4 have all these individual prefixes via router number 3, all individual prefixes 10.1.1.0/24, 2.0, 3.0. And guys, if any network will goes down, will our router 4 generate query message? First of all, if R4 want to ping to 10.1.1.1, R4 will forward traffic to which router? To router 2 or router 3? I'm getting some noise, please. If I will ping 10.1.1.1 from router number 4, router 1 will forward traffic to which neighbor? Yeah. Why router 3? Because of longest prefix match. And then router 3 will forward it to router 1. But when this interface will goes down, or let's say this interface will goes down, now question is, will router 4 generate query message? No, it will not generate query message. It will lose these all prefixes, it will remove from the table, but it will not generate query message, because until and unless summary route is available in the table, router will not generate query message. So that's why I'm saying, to reduce the query message, we have this option also to summarize the prefixes. And see, whenever we will perform summarization, here I have one problem. Let's suppose I have summarized this network 10.1.0.0/22, right? Router 2 is going to advertise it to router number 4, and router 1 have advertised the summary dot 10.1.0.0/22 to router 3. Router 3 will forward it to router 4. Now guys, all router have what? Summary dot. Router 2 have summary dot 10.1.0.0/22 via R1. Router 4 have summary dot 10.1.0.0/22 via, let's say, either it can perform load balancing, or let's say via router number 2 net meter. Then router number 3 10.1.0.0/22 reachable via which router? Let's say via router number 1, and here this network is reachable via, let's say, router number 3. Now what will happen if this network bill goes down? See the issue. Issue is, now if router 1 will ping to 10.1.1.1, source IP anything, destination IP 10.1.1. Router 4 is going to compare it with this with their routing table. Is route available in the routing table? Yes. Next hop is router number 3. It will forward to router 3. Router 3 will compare it with their routing table. Route available? Yes. It will forward to router 1. Router 1 will compare it with their routing table. Is route available? Yes, summary route is available via router number 2. On router number 1 also we have summary route, right? Let's say via router number 2. Let's suppose you will perform summarization on router number 2. Then router 2 is going to advertise that summary route to router 4 will advertise to router 3 will advertise to router 1. Even router 2 will advertise that summary route to router number 1. So all router have summary route in their table. So router 1 will forward traffic to which router? Router 2. Again router 2 will forward it to router 4 by checking their routing table. Summary route is available via router number 4, or if it is available via router number 1, then it will forward to router 1. Again router will check their routing table and summary route is available via router 2, it will forward to router number 2. So like this loop will form in the topology, yes or no, because of summarization. Loop will form in the topology. So that's why whenever we will perform summarization on the router, it will make one entry in their routing table for that summary network. Like on router number 1, if you are summarizing this network, it will make one entry in their table 10.1.0.0/22, and exit interface is null 0 interface. Exit interface is null 0 interface. Now if router is receiving a traffic for 10.1.1.1, guys, this IP address will match in this entry, and for this entry exit interface is null 0, then router will simply discard it. That's why whenever we will perform summarization, you will see it have one summary route with null 0 interface, like on router number 2. So IP route, is summary route available? Yes. Exit interface null 0. So why this router have installed this network in their routing table? To avoid the loop. Right? So whenever we are going to perform summarization on the router, it will install that summary route with null 0 interface. Now I think in EIGRP I have covered all topic. Let me verify once. Metric calculation. Dual algorithm, diffusing update algorithm, used to find best path from the topology table. So router will run dual algorithm on their topology table to find best path. How? With the help of FD and RD value. And there is one feasibility condition. If feasibility condition will match, if there are more than one path available for the destination network and feasibility condition is matching, then router will install both path in their routing table, right? Now you know the CD, RD. CD is also total metric from source to destination of all path available. You don't need to learn CD, by the way, it is not in your syllabus. RD, reported distances, in your syllabus, means distance advertised by neighbor. Here you can see the feasibility condition. RD of another path should be lesser than FD of successor, or should be equal to FD of successor. Then EIGRP table, neighbor table, topology table, routing table, types of messages, EIGRP neighborship parameter, command adjacency, null update, main update, RTO query, split horizon, route poisoning. So for the split horizon, make sure you will design one topology, hub and spoke topology. Type of neighborship, we have seen a static neighborship also. So guys, in case of hub and spoke topology, we need to configure static neighborship. right? So dynamic neighborship static is useful when there is more than two routers in a single broadcast domain. In a single broadcast domain, if we have more than two neighbor, then we should configure dynamic neighborship. But for the point to point, we should configure always what? Static neighborship. Is useful when there is only two router in a broadcast domain. So even if you are connecting two router together, R1 and R2, in this scenario also you should configure a static neighborship so that router will send messages on unicast address. How to reduce query message? By adding feasible successor with the help of summarization and EIGRP stub. What is EIGRP stub? Non-stub router will never advertise query toward stub router. So as I told you, in your hub and spoke topology, you should configure spoke routers as stub router R1, R2, R3. Then in between we have internet. So if this router is configured as stub, so see, non-stub router will never advertise query towards stub router. Now router 1 will never generate query for router number 1 because router 1 is non-stub router. So router 1 will not generate query for stub router. Stub router will never receive query message but can send query message. Stub router will never forward one neighbor route to another neighbor connected, and summary route advertised only by stub router, and that was the issue when I had configured stub on R1, and this is the command. Equal cost load balancing and unequal cost load balancing with the help of offset list and with the help of variance. Then we have got route filtering. Done. So now you need to perform lab by yourself. In EIGRP, multiple labs are there. If any question, please ask. See, I am teaching EIGRP after a long time. R1, R2,